Hello world, it's Angela. I want to take you through a workshop I did recently at MaptimeSF. Shout out to Maptime HQ. Should bring Maptime to a city near you, right? Alright, so this workshop was about using d3.geo to make maps in the browser. And I'm going to do this in 3 parts. So this is the first one, and what we did first is take you through the landscape of d3.geo by looking at a bunch of examples. I think it's been made pretty clear that a really good way to learn D3 is by looking at examples, copying them, tweaking them, adding your own data, just trying to get something to show up on the screen and then trying to make it into what you want to see. So, what I did first was take people through a little bit of what D3 was. The audience, some people had done a bit of web development, a little bit of web mapping. Some people had almost no web development exposure, all using GIS software. So there's a wide range of skills and awareness of this particular stuff. So, I think a lot of people watching these videos already know what D3 is, but just in case, you got to go see the examples, because it's, of course, more than a charting library. It's not a charting library. We kind of called it a Swiss Army knife of data visualization. All kinds of tools and things, functions, utilities to help you make, represent your numbers as pixels in some form, and usually in some interactive way. So, of course, there's force layouts and mapping functions, and you can do all kinds of stuff that isn't even really data viz, but it's fun. There's stuff that you might not have seen before, or of course there's things you have. So yeah. So D3, you can represent your data in all kinds of ways, but we specifically want to check out mapping. So the D3 community is also very heavily examples based, and there's all kinds of great examples from Mike Bostock, the creator of D3, but also the rest of the community. Some really beautiful things that maybe for more fun, or that example's not on mine. Some interesting techniques you can do here. So one of the things I wanted to kind of stress is, this is a gallery of almost 2,000 D3 examples. Right now I have it filtered by map. You can filter it by all kinds of other charts. You can filter it by author. So if there's something you want to do, chances are someone's done something similar, or at least something that could give you a starting point. So, I think this is really important to be aware of as you're trying to learn and trying to accomplish something. Of course, we always recommend looking at Mike Bostock's blog for explanations of how stuff is done. He has a few things about mapping, some tutorials, which I specifically call out in the list to the left. But you can also see the way that he's pushing the boundaries and applying this stuff. Also, his blocks are a great way to see the latest stuff that he's been working on. Some beautiful things, some interesting things. A great place to get code if you want a place to start. So another thing we pointed out was that there's a lot of projections included in D3. So, not included in D3. Here's a library of extra projections. And so if you're not familiar with mapping too much, there's a lot of ways to render a map, because the world is a globe, right? More or less a sphere. And usually we're showing maps on 2D screens. So you can imagine that cutting up the globe and trying to make it flat is you're not always going to end up with the same result depending on how you decide to make it flat. And we're very used to this Albers projection. It makes the United States look good, but doesn't really help other places. Let's see. Well, this is the extended ones. The standard one that Google uses a Mercator. So this one is also included in D3. In Google Maps, you're generally looking at Makeda map. It does kind of screw with the sizes of things that you see. Greenland's huge, bigger than Africa, which doesn't make much sense. But that's the way we're used to seeing it. But there's all these other ways that you could represent the world, depending on what you need to do. And it's really cool because if you want to maybe not make a map about the United States, there's ways to represent whatever place you're interested in a nice way. So another thing that's really good to be aware of when you're trying to learn how to do stuff with D3 is this BlocksBorder. It's basically a search engine for D3 functions. So you can actually find examples that use specific functions, and so these are using this Winkle3. I don't even know what that function is. Probably projection. So you can actually find very specific uses of whatever you're trying to figure out. This is cool though. So, so yeah, if you're looking at the D3 API, right, and let's say we're gonna find some d3.geo functions, and we're curious about how to use the graticule function. There's this stuff here which tells you more or less exactly what happens, but not much about how to use it or how to use it with other code. So let's look up the graticule, right? And here, it looks like it's specifically just rendering the graticule, and we see the code. Not much code. Should be able to figure that out, right? So this is a really key resource. Shout out to Irene Ross, who made this on a plane flight home from the D3 Unconf we had not too long ago. Really amazing addition to the community. Really helpful. So yeah, take advantage of it. Alright, so I wanted to point out some cool projects in particular that use d3.geo. Just things that take us a little bit beyond what you might do with the desktop software that's been in use for so long. What you can enable when you bring this stuff online. So let me launch a couple of these projects by my friends at Halftone. This one's really cool. You can see how the United States went from different colonies and stuff like that to the States over time, and this is a technique called small multiples. So as we scroll down, you can kind of see the states creeping across, and when that happened. Of course, there's the Civil War, so we see that happen here, and here it is as we know it, apparently in 1959. So yeah, this is really interesting. I mean, a lot of this was the work was actually preparing the data to do this, but once the data was prepared, D3 made it very simple to just lay out create all these maps and lay them out like this. This is a really interesting use of Voronoi diagrams to show world temperature over time. So we can go to different times, times of the year of different years, different months, and each of these cells that are colored differently are actually temperature stations, right? So temperature sensors, and you can see that there's very detailed stuff in the United States and in Europe and some parts of Europe, but there's also very large cells which don't have as many sensors, right? So you can imagine there's a dot collecting data for each of these, and Voronoi allows you to kind of give a broader sense of how things are, sort of an approximation, without using circles of different size radius, which makes it harder to see the overall patterns, right? That it's cold in the north and warm in the south. But yeah, this is a really cool interactive thing that D3 made really possible. Let's see. So another thing that I'm a big fan of is Minimaps, and this isn't necessarily actually a geographic map, but this technique can be used, with d3.geo or in other senses. But yeah, I love Minimaps. I think they're a really sweet way to show, the bigger picture at the same time as you're exploring something specific. You can of course check out the code to see how it's done. Here's something cool. For doing data visualization. If you want to show all the states at once or a bunch of different geographic locations, automating this display is made possible from D3. It's not that much line of code, a little bit of math here with comments too if you want to know. So now you could color these by some kind of data, or use this in telling a story about comparing the states. And giving them uniformly sized thumbnails. So let's see what else. This is a really really beautiful visualization of how wind patterns over the world, and you can see this here is actually all made in D3. If you look in the code, the country boundaries, the land boundaries, are done with SVG generated by D3, and all these particles which are representing the wind are rendered in Canvas but managed by D3. So this is a really great example of doing something that needs high performance and offloading the pieces that need that into Canvas, but still managing all your data and your data transformations with D3. And I'd like to shout out to PixelBeat for sending me some of these links. And I'm happy to record this video, since a lot of people across the world can't be in one physical location when we're giving these workshops. Hopefully this helps some people out there. So speaking of across the world, these are all tweets about the situation in Ukraine, and using D3 to make this map, you can see night and day. This is current, right? And these little orange dots are all tweets. So it shows, it's really, D3 makes it really straightforward to take a list of data like this, geolocated tweets, and show it on the map, and then give you some context for where people are talking about this stuff. This one's just for fun, an exploding load. Just something you can do by mixing two different functionalities in D3. And this is Andrew Hill from CartoDB. Here he made a more serious map where you're showing meteors landing in different parts of the world, and the size of the circles that they grow to is driven by the data of the size of the meteors. And this fading out and growing effect is a very simple couple lines of code in D3. You can see down here. It's just this transition. So D3 makes it very easy to do this kind of animated thing to really tell a story beyond a static map or a static chart. Another person I think is really important to be aware of is Jason Davies. He's just a math whiz and a programming genius, and he's contributed the most to D3 other than Mike Bostock. And he's done a lot of geographic work. So he actually has a page of map-related projects. Here he's implemented a bunch of projections. He's stuff that must have been in the books as math formulas, and he's brought it to life, as well as some really interesting visualizations that he's done in order to make sure that the algorithms are implementing work properly. So they're clipping. These are different stress tests and ways to make sure that the clipping map is working properly. This one's really great. So I call out a couple of his projects which are really inspiring. So this one has all of the projections that they've implemented in JavaScript in the browser in real time. You can reproject your geospatial data to any of them, transition between them. Here's Makeda, we know so well. Here's Polyconic, which I don't know well at all. Yeah, so what's really impressive about this is there's a very well-known or widely used, I'd say, library called GDAL, which is a super Swiss Army knife of GIS functionality. It's written in C or some low-level language. I guess it's been ported to a bunch of other ones, and it's usually what you use to convert huge array of file formats and projections to other ones. And they've gone and sort of re-implemented a lot of these so you can do it in the browser, which is really nice. You can see, once you get stuff into D3 and you have the geospatial data as data, and you're thinking in the D3 way, you can start doing this small multiple stuff to lay out all the countries by area. So these are sorted by their area, and you can visually see the size of the countries in relation to each other. So it's really interesting. Let's see here. This one I love. This is visualizing if you were to dig in the backyard all the way through the earth, where would you end up? And most of the time, you would actually end up in the water. Only in South America and parts of China and Indonesia would you actually reach some other land. And even then, there's just not that many places where that happens. So this is a really great visualization in that it could answer your question immediately anywhere in the world just by layering these two things in the proper way. Yeah, really impressive. Finally, there's a nice utility function. So D3 has a few things they're called behaviors, like dragging, that make it easy for you to manipulate your visualization with certain interactions. And so this page demonstrates a transformation, a d3.geo.zoom, which is both dragging and let's see, here we go, zooming in and out for geographic code using d3.geo. So if you look at the source of this, and I'll do this in the third video, we can use this library to make our maps into draggable and zoomable with very few lines of code. So another thing I think is important to be aware of is Topo JSON, because we want to show our geographic data on the web. We need to have it in a format that we can interpret in JavaScript, and a lot of people have used GeoJSON for this, and we'll just look at some GeoJSON real quick. And this is a way using the JavaScript object notation, which JavaScript developers love to use. It's very easy to consume in a JavaScript program to let encode geospatial data. Just get all kinds of stuff, points, polygons, all that. This rather than shapefiles, right? So the problem with GeoJSON is that it's fat. It takes up a lot of space. It's a lot of text, a lot of characters. And Topo JSON is a more efficient format. It also allows you to sort of reuse lines that are touching. So let's just open some of these things, and we can see. So here's a lot of county, all the counties in the U.S. Encoded by color, but I guess by the area, from blue being large counties, red being small counties. It's just very efficient representation in this JSON file. Here, encoding all the counties as circles, rather bounding. The U.S. Atlas is a project Mike Bostock put together in order to make it more convenient to process geospatial data from the United States Atlas and turn it into Topo JSON so that you can use it in the web, and these are examples of what you can do with that. Really amazing stuff. There's just a world map represented in Topo JSON. So, you can find out more about how Topo JSON works. Here, it's a bit, mathematical, but it's also kind of cool to see the algorithms kind of happen. But if you just want to use it to render stuff, I'll show that in the next video. And this is more for advanced people to really dig into it. If you really want to take control of the geospatial data that you're rendering. But just converting shapefiles to Topo JSON. I've put some links here. GeoJSON to Topo JSON. These things are well documented and can do. Here's the tutorials finally that you can follow along. This takes you from the source data to putting it in the browser. I'm going to do stuff in the next two videos, which is preparing some data, or assuming you already have Topo JSON or GeoJSON, and making the maps in the browser, because I think between all these links, the actual command line stuff is more about just like reading for your particular computer how to set that stuff up and like downloading files. It's a little tedious, but it's not it's not hard. It's not too hard, and it's well documented. Also on Stack Overflow. Also, here's a tutorial on putting D3 on top of Leaflet, which is really convenient because Leaflet's a great library for showing tile data. And I'll show you how to do that in the second video. I'll take you through some examples of that. So yeah, these are the examples. I recommend perusing them. Really, if you see something you like, use that to get you started. And yeah, see you in part 2 and 3. All right.